great to be here. My name is Tim Swanson, and I'm Director of Market Research at a company called R3. And we've assembled a great panel, a virtual panel of well-established experts in this field of a nascent field, as it were, of distributed ledger technology and blockchain technology, as it's typically called. And what I'm going to do on this panel is ask a variety of different questions and see how the organic dialogue takes off. So without further ado, I'd like to start off with Elaine Shi from Cornell. Elaine, could you first tell us a little bit about what you were working on and this new one-size-fits-all consensus solution that your team at Cornell has been looking at?
So yes, and we have this new protocol called Thunderella, and essentially, now with this new cryptocurrency, and there are all these industry consortia and companies, and everyone wants a blockchain solution. And at the core of the blockchain solution is like a distributed consensus protocol. And the idea is like, you want to basically replicate your critical database. You have financial transactions, you have other mission critical database, and it's a bad idea to like store it on a single server. So this, in some sense, it's like a classical problem in distributed systems and has been studied for 30 years. But perhaps somewhat surprisingly, like all these classical solutions kind of don't really apply to these emerging applications because so these classical solutions, for instance, have been widely deployed in companies like Google and Facebook, and they run something like a Paxos-based protocol. And Google, for instance, developed this system called Chubby, which is based on a variant of Paxos. And then there's the open source equivalent called Zookeeper. And apparently, every other company like Facebook, Uber, like all these companies, they use Zookeeper. But these like are a very different point in the design space because they're like 5 to 10 nodes, and they want like microsecond response time, and they don't want to use any crypto, and they're willing to assume benign assumptions like crash fault instead of like Byzantine fault. But for these new application scenarios, like if you want to design, let's say, a consortium blockchain across multiple banks, like I've been talking to people in China, and for instance, China Central Bank is interested in doing this consortium blockchain, and there are hundreds of banks in China. And if every bank contributes 10 nodes, you are talking about like at least 1,000 node scale. And in this kind of, setting with multiple organizations, larger number of nodes, people don't know what is like the dream protocol. Like right now, what's happening is kind of like everyone's rushing to create and implement their own protocol. And it seems like that there's this hope to fill in, this shouldn't be something that you and we each create our own. It should be like, we may want some kind of unifying open source version of the protocol, which kind of addresses, let's say, the most demanding of these scenarios, and then everyone can just use this single platform. So Thunderella is kind of designed to address that need. And the nice thing about the protocol is like it's very, very simple, and it's very fast, and it scales very well in terms of bandwidth. It scales to large number of nodes. So partly, the reason, why is everyone rushing to implement their own protocol? Partly because, so if you look at the space, there are classical protocols and there are modern blockchains. And these, like from a technical and mathematical perspective, they are kind of fundamentally different approaches. So classical protocols are very complex. Like if you look at protocols like PBFT and Paxos, they have a very clean normal path. Like the normal path is the leader yells out something, everyone votes, and then people just all confirm. So it's like very clean. But then when you start talking about that the leader can fail and you need to kind of recover, then the recovery path is like very, very complicated and very messy. And then you also kind of need to run, even for the normal path, you need to like run the protocol for more rounds. And some of these rounds are just kind of amplifying the security and getting ready for the recovery path. And so these I've been talking to people who are implementing these protocols, and just like it's very difficult to implement it correctly. And then for large scale, like multi-organizational deployment, operational maintenance is also going to be a huge headache for this kind of protocols. And some companies like Chain.com, and what they do is like really a not very ideal solution, and then they're just kind of ditching the entire recovery path, and they are implementing this normal path. But what's going to happen is, like, if the leader crashes or if your system is under attack, then basically the whole thing will come to a halt. And what's worse is that to recover from this outage is non-trivial because it requires global coordination. Like, you have to basically manually sync every node and then reboot them. So
wow, it sounds like it's a very difficult situation, and actually this kind of dovetails into what Sarah's been working on with scalability. And not to take too much away from what you're talking about, Elena, but at a high level, Sarah, I know that you guys have been looking at scalability issues at UCL. How do you see some of these? I know that you wrote a paper on top 10 problems or challenges in this space, and Elaine just mentioned a couple of them. How do you see this being resolved in the short run, or is it a long run in order to, say, scale 1,000 or 10,000 of these nodes, assuming that this stuff is implemented? Is that doable with existing technology, or do you actually need to invent something like what Elaine's team is working on now?
I mean, I think there's, sort of distinctions we have to make between the goals of a given system, right? And those are all very dependent on the setting in which we want to deploy these solutions, right? So, the things that, blockchains have been aiming for, at least currently, is a very adversarial setting, right? Like, it's this setting where everyone's mutually distrusting, where there's sort of no, like, we can't even select like a set of any size of nodes where we'd be willing to say we trust anything about that set. So it's a very adversarial setting, and the things that Bitcoin and other blockchain solutions can achieve in the face of that sort of very adversarial setting is really impressive, right? This notion of full public verifiability, that I can check, because I don't trust anyone else, that everything is happening as it should be happening, right? And this is kind of like necessary in a setting in which you don't want to make any assumptions about trust. But it also comes with, I think really significant costs, right? So aside from the sort of like, I guess what I would call cost effectiveness of the consensus protocol, whether or not you take out proof of work and put in something much more efficient, you're still left with these issues of scalability in general, right? So for example, full nodes would still need to maintain the full state of the blockchain. So that means, the whatever 120 gigabytes of the Bitcoin blockchain currently is. And it also means that we'd be insisting, again, for this full public verifiability, on full state replication across all nodes, right? So every node has to maintain the whole blockchain, and that's kind of what we're going with, right? So of course, Bitcoin and other cryptocurrencies have introduced these SPV clients, but basically we know that it can't be the case that everyone runs an SPV client, because then you lose all these verifiability properties. So that's kind of the state of things, and obviously that's fine, and that's a very important setting to be looking at. But realistically, in a lot of settings, especially in institutional settings, we don't need to kind of make that trade-off quite that way, right? Like, we are willing to make different trust assumptions. And so that's what this paper that you're alluding to, I think, kind of points out. So the paper is called Centrally Banked Cryptocurrencies. And it's basically saying that if you're in a setting like the setting that we were motivated by, where you have a central bank who may be able to take on certain roles, or actually in particular, the trust assumption we make is that there is a set of nodes that can collectively as a set be trusted not to all be colluding. So if you are willing to make that assumption, then yeah, you can get much better scalability properties. I'd argue much better than you could get with almost any, fully distributed, fully blockchain kind of solution. And yeah, so we've sort of explored that possibility in this paper. Central banks have kind of been looking at it themselves. And so, I think there's sort of benefits to having a one-size-fits-all approach, because there are a lot of settings that, do make similar trust assumptions. But at the same time, obviously, we want to be keeping in mind, what are the requirements, essentially, of the setting in which we operate, because that may lead to very different points on this design spectrum.
Thanks. That actually dovetails into the area of expertise that Andrew Miller at the University of Illinois at Champaign. You guys have been looking at a variety of different areas of research. And in fact, I think that something that you looked at last year was the DAO and how it effectively had a collapse. And I know for listeners, the DAO is maybe something they've heard in passing at most, but can you explain how the intersection of the code and the breaking down thereof could lead to some serious problems for those who are participating on the network?
Sure, no problem. So I'll try to give a short, as quick as I can, a self-contained description of the story of the DAO and what lessons it has for us. So the DAO was one of the most exciting and first really prominent examples of a smart contract on the Ethereum blockchain. So this was a program that did something, it runs on the Ethereum blockchain, but it did something unusual, which is it was the first of its kind of a new kind of decentralized crowdfunding system that was supposed to be a really interesting game experiment in game theory. So it's like a hedge fund. You can think of it as like a hedge fund that people would chip in money to. In exchange for chipping in some money, they would get a portion of ownership, voting stake in the decisions that this hedge fund would make. There were a whole bunch of other sort of complicated rules. The main fun of this is that unlike an ordinary hedge fund or crowdfund like that, there's no manager for it. It just runs in the form of this computer code that says how the votes are enacted and all of that. Now, this brought up all these really interesting game theory issues about how, given a certain amount of ownership stake, you might have an incentive to vote yes or vote no on a particular proposal for what the DAO should do. So by all expectations, it should have succeeded or failed because of really complicated interactions with new forms of game theoretic kind of mechanisms. But what turned out is that it failed spectacularly for a completely different reason, which was far more simple and in hindsight avoidable, which is that it had a programming flaw. So it had a programming flaw, which was a bug that was overlooked by everyone who had written the code or audited the code. And essentially this flaw allowed an attacker to deposit a little bit of money into the DAO, but then actually withdraw the vast majority of the money in it, far more than they had taken. They essentially got to take all of the money out of the DAO and drain it. The programming error that occurred was actually, my version of this story is that this was a known programming error. We had actually talked about this I'm familiar with this particular topic because in 2015, we actually gave a report to the Ethereum Foundation analyzing some aspects of their design of their new programming language, the programming language you use to implement these smart contracts. And even at that time, one of their first example programs of a crowdfund campaign that was included along with the Ethereum code repository exhibited this particular kind of weakness that would then, years later be exploited or, remade as a vulnerability in the DAO. The significance of this is that it underscores some of the difficulties in interacting with smart contracts, which are just computer programs that run in a computer system. It's the blockchain, but the blockchain doesn't, guarantee that everything works as you intended. Just like software in every other domain, software tends to have bugs in it and flaws in its design. Perhaps some of the expectation was that because this program code is publicly visible, it was open source, it's sort of stored in, tamper-proof form in the blockchain itself, that nothing could go wrong with the code, but that turns out not to be at all true. And there's lots of cases. Normally, bugs in code can have expensive consequences. Like, I think it was just the other day that an entire fleet of airline flights were canceled because of a, IT-related problem, no doubt caused by, if not a hardware failure, then, potentially a software failure. So in the smart contract world, this is no different. Now you have computer programs that are written, and if they contain flaws, they can cause money to be directed places where it shouldn't go or make it vulnerable to an attacker draining it out of wherever it was placed. So to me, this underscores a couple of really important insights that the research community is now working forward on. So first is that we really need better tools for analyzing what software does. So the current way of validating code on the Ethereum blockchain is just to look at it. The company that produced the DAO code did hire a security auditing firm, but they either weren't aware of and didn't look for this particular kind of hazard, certainly now in hindsight that the other part of the story was that they drained something like about $50 million worth of ether from the DAO at that time. So now with the benefit of hindsight, certainly everyone who goes and looks at a contract to inspect it is going to have this kind of bug at the top of their mind to look at. We don't know how many other bugs there, that haven't had such a visible exploitation and so might be missed by security auditors. So really what we need to do is to apply more systematic kinds of program analysis tools to automatically identify bugs or rule out large classes of bugs. And again, with the benefit of the hindsight, after the event of the DAO, there's been a really large burst of research attention and research effort in improving and applying existing tools. Program analysis is a really established topic, but now we're looking at what it means to apply program analysis tools in this new cryptocurrency and smart contract world. There's several other kind of dimensions of this. I maybe won't go into them until prompted, but the last point that I would make is that this really underscores a sort of important gap in the decision-making associated with cryptocurrencies. So the DAO and the DAO is the first one of these, I think, ICO-style token sales, right? And these are now a repeated pattern in many different ways. If you're a potential investor and you want to potentially deposit a bunch of money into a smart contract-based investment plan, you have a couple of choices. So typically, if you get there first, right, you want to be one of the early adopters, one of the first people to invest in a token, because typically the prices are lower when you get in early, right? So you may have a fear of missing out. You may miss your chance if you take too long to decide to invest in this. The early adopters usually get the biggest reward. On the other hand, if you want to be conservative, you may want to wait until a sufficient amount of validation or due diligence has been performed on the contract. Or you may want to invest in some of this due diligence yourself. But then that cuts into your time, right? That adds some delay, so you may not get as big of a cut of a reward if you wait. So while it's easy to say that, oh well, what we need are better validation tools, there's even a deeper question of how do you decide how much effort to put in prudence or waiting for the validation to take place versus getting in right away. And so this is still an ongoing debate that's occurring in some fashion with the new post-DAO forms of cryptocurrency-based investments.
Wow, yeah, you touched on quite a few very interesting topics. Unfortunately, we don't have the time to go through them all, but I did think it dovetails into the expertise of our next panelist with Angela Walsh. You're a law professor at St. Mary's, and you've written quite a bit on the topic of governance, fiduciaries, responsibility of, for example, if developers put in code, are they the ones who should be held responsible in case there's a bug and it crashes and people lose hundreds of millions of dollars? So you've written a bit about this. It's obviously sparked a lot of debate, healthy debate, as it were, in the community. And I was just wondering, since you've been looking at this space now the last year and a half, have you seen any kind of maturity taking place in terms of people trying to be adults and looking and taking responsibility for the bugs, or do you feel that that's not needed, or like how do you see the current trend in the community in terms of code and fiduciaries?
Oh, great question. So yes, when I wrote that op-ed last summer, I got basically crucified by a lot of people on Twitter that I totally misunderstood the point of these technologies, as well as the whole push towards innovation, that I was anti-innovation and anti the whole open source software movement, to say that people should potentially be responsible for the consequences of the code that they design. There's been a lot of talk about it since then, and I do think that there is some maturing in the industry. I have actually had a lot of people say that they think that this needs more exploring, and it absolutely does. I don't think the issue is anywhere near resolved. I don't think it's a simple thing as just saying, oh yes, all software coders are potentially fiduciaries to those who rely on their code. I think it needs to be a much more nuanced analysis. Some code is more important than others, right? Code in critical systems is potentially a type of code that people should be accountable for harm that it causes. Code in less critical systems, like music sharing or something, is very different than code in a financial system or a voting system or other important systems that people are contemplating using blockchain technology for. So I think that the issue is now on the table, and I see the issue come up, and the need to rethink it in a context broader than just blockchain technologies. I mean, I think it's a topic that needs to be considered for code outside that setting as well. We have seen many prominent crashes. We have seen problems with some significant open source software projects that underlie the internet infrastructure. And I think it's just time for a rethink of some security practices around those, some accountability practices. And because I think it is such a paradigm shift in the way of viewing the creation of this code, that's why it's potentially controversial.
Thanks. And I know that our final guest, Zooko Wilcox O'Hearn, you're actually the only non-academic on this call right now, but your team has been working on some pretty cutting-edge technology at Zcash, and specifically something called a zero-knowledge security layer. So rather than diving into snarks and doing all the moon math and everything like that, can you explain how your system or systems using this type of math or these type of cryptographic tools can provide security, and how do you account for, say, something like someone like Angela saying, how do we know this is actually secure enough to put private information on there and have it replicated, and making sure people that are not authorized or not given access to the visibility rights of that don't end up with those types of visibility privileges? How would you describe that in that context?
Well, that's a hard question. Yeah, hi, I'm Zooko. I'm not employed by a university, but I have co-authored some academic papers in the past, but I don't know nearly as much about cutting-edge science as the first three panelists, and I also don't know the answer to the question Tim gave me. It kind of seems like when Bitcoin came along 8 or whatever years ago, academia was a step behind of the open source experimental hackerdom that Bitcoin came out of. And then that stimulated academia to realize that there was a whole new field of scientific possibility here. And now, today, it seems like practice is a step behind of academia. There are all these new results from people like the other three panelists who talked at the beginning that seem like they probably solve important problems that practitioners are currently stumbling over. But at the moment, as far as I know, practitioners haven't successfully moved any of that academic research into practice. And then as for law and policy, I think that's at least one step behind of the other two at this point. And your question was something like, can we use technology to protect confidential data in these kind of systems? Was that the question? Or how you can be sure is a better?
Yeah, going back to some of the papers and articles that Angela has written about in terms of if you build systems that don't live up to the assurances or guarantees that the developers or entrepreneurs around those developers claim they can, how can we hold those individuals accountable? And I'm not trying to single out Zcash. I'm just saying, you guys are talking about providing security and confidentiality and potential privacy for users. How do you see this market maturing in terms of not only providing the actual technology, but providing the businesses and the assurity around those businesses around that technology? Yeah. Do you feel it's still too young, or is it just one of those, like, it's just by growing pains?
I think it's growing. I'm not sure if it's growing pains or growing whatever the opposite of growing pains, growing successes. That the technological improvements that have come out of both practice and academia over the last just 5 years do reduce losses, or could. So those of them that have been deployed in practice can protect users better, but there's always there's a sort of homeostasis or something. Maybe I'm using that word wrongly, but if you provide a service or a product that protects people, then it protects people better, then they're going to risk more, right? Because they can benefit more from relying on that thing. So there's been this arms race on the internet for much more than 5 years, for about 20 years, where attackers have gotten better and better at exploiting people, and defenders have also gotten better and better at providing safe systems. And so I think what I'm getting at is that it is neither the case that there's going to be a silver bullet that's going to be so successful at protecting people that you don't need law and recourse and everything else. But nor is it the case that we just have to put all of our faith in the human layer of law and recourse. In fact, the technology layer is improving and is helping people more and more, but it's never going to be sufficient, right? It's never going to be everything you need. I don't know if that answers your question at all, but that's what I'm thinking about.
Sure, that's very fair to make a statement like that. And speaking of guesses and estimates, and I know that we're winding down the panel. It's just unfortunate because all of you guys, we could spend hours and hours talking about these topics. But I'd like each one of you to effectively say how long you think it may take in years or months even. For example, mainstream usage. I don't mean cryptocurrency usage. I mean the actual technology behind some of this tech being used by institutions or enterprises. You could go to these different fintech events. People will say, "Oh, it's just a couple months away," and others saying it's decades away because of the integration and compliance costs and so forth. So I'd love to hear what each of you guys think in terms of timeframes, and maybe one or two of the main reasons why it takes that long or it doesn't take that long. Let's go ahead and start with Angela.
Okay, sure. So I think like one of the other panelists was saying, you really have to consider in what setting the technology is being deployed. So I think there will be a wide variety of lengths of time that it takes to get implemented. So I would say, at least this would be my hope, that in less critical settings, it would, be the sooner, maybe 3 to 4 years or something like that. And in more critical settings, like the financial infrastructures or potentially like a central bank digital currency or something like that, we would take a lot longer to figure it out. It's interesting to me that Bitcoin has been here now since, end of 2008, early 2009, and it feels like it just started in that I feel like the understanding is so immature that we're still very much learning and experimenting. So I would hope that the maturing takes place before the implementation. That probably sounds silly to say, but I'm not sure that we're on that track right now.
Okay, great. Sarah, what do you think?
So yeah, similarly, I would sort of categorize it, depending on the settings and also depending on the technology, right? This term distributed ledgers is so broad. You could say, oh, I'd expect a central bank to be adopting some version of that, where that could be like Cassandra or something. That could happen quite quickly. And similarly, in less critical settings, we're already seeing sort of musicians and people like that kind of experimenting, engaging a little bit with, full-on blockchains, things like Ethereum. In general, I'd say overall, maybe 5 to 10 years, but that's kind of a random estimate, really. We'll just have to see where these things go, see what more, they have in store for us before we can really see who's going to be willing to take that risk.
Thank you. And Andrew, what about you? You feel it's shorter or longer, or what's your take?
Yeah, I don't really know what to do with that question. People are already using these in some cases. NASDAQ, for example, had some use of, I think, like an actual live rounds system that could trade actual equities or securities or something that NASDAQ trades with live. I know that I agree with what Sarah said, that blockchain technology, distributed ledger technology is really such a broad and amorphous term that it could include any kind of distributed system that is already used. Like, there are already deployments of fault-tolerant systems, and I think that they'll continue to adopt more and more parts of what we call blockchain design. So yeah, there's no moment when it'll happen, right? It's already happening and will increase gradually.
I love that response. Actually, it ties in with a paper that Angela wrote. Unfortunately, we really can't go into, but she talked about the different definitions of what a blockchain is and how amorphous it is. So I'll put the final word with Zooko. I know that you guys have launched a system this last October. Do you consider that roughly the same vein as what Andrew was saying with these different nascent systems in NASDAQ, or are you considering it like in terms of a central bank digital currency, in terms of how long it will take to, assuming this stuff is integrated and I guess digested by these institutions, do you feel that that's ways away, or do you feel that there's in the short run that it might come up faster?
Yeah, the thing we launched in October is called Zcash, and it's an open cryptocurrency, an open blockchain that anyone on the internet can connect to. And my answer is that new kinds of product take about 5 years to start getting market traction, to come to market and get traction, and then they take about 10 years before they have the big mass payoff. And but I'm going to start the clock about 3 years ago. It was about 3 years ago that various people started working on what's now distributed ledger technology for enterprise, and it was about 3 years ago that we started working on what's now Zcash. So I'm going to say in about 2 years, we're going to see market traction where there are a non-negligible number of people relying on these new technologies for their commerce. And then in about 7 years, we're going to see it being reaching some of the promise that we've been hearing about for the last 3 years.
Great, wide range of opinions and views. I'd like to thank all the experts and panelists on this virtual call, and looking forward to seeing more of your guys' research as over the coming months and years. So thanks again for your time, and have a great weekend.
Thank you very much.
Thank
you.
you.